let's consider another examples. A conservative force acts on a point mass. Okay, so we have the point mass here of the 1 kilogram moving along the x-axis. So this is the one-dimensional motion. Okay, the potential energy relating to this force is equal to this one. So this is the function of the potential energy such that the x must be greater than the 0. Okay, so the x is always positive. So okay, so let's consider this function first. We have a constant, right, the 4 in the unit of the joules per meter, and then multiply with the x here. The x is the position. So in this case, it means that the x must have the unit as the meter, right? So then unit of the x we can send out with the joules per meter here. Then we can get the energy in unit of the joules. And then multiply with the exponential function, right? The e to the negative x over the 4.00 meter. Okay. So note that when the x equal to the 5.0 meter, the kinetic energy of this point mass is equal to the 2 joules. So now for the part A, we need to calculate the total mechanical energy of the point mass. Okay, so let me move it here. Okay, so we have only the conservative force exerting on the object, right? And then on the same level, okay, on the same height level. Okay, it means that the total energy of the point mass must be conserved. Okay, then we can use the conservation of the energy to solve for this one, right? So we can get that. Okay, the total mechanical energy of the point mass. So let's say the E. Okay, let me just write down first. Okay, the total mechanical energy of this system, okay, is conserved. So then we have the E, right? The total energy equal to the kinetic energy and then plus the potential energy. Okay. So which information do we know? We know that when the x equal to the 5 meter, right, the kinetic energy of this point mass equal to the 2 joules. Okay. So we know that at the 5 meter, the k here equal to the 2 joules, right? So how can we find the u? We can just plug in this x equal to the 5 meter into this equation, and then we're gonna get the potential energy of this point mass, right, at this position. Okay, so then let's say that okay, as the x equal to the 5.00 meter, right, when the x equal to the 5.00 meter, okay, we have u, okay, equal to minus the 4.00 joules per meter, and then times the x, which is equal to the 5.00 meter here. Okay, and then times the e to the negative of the x, which is equal to the 5.00 meter, and then over the 4.00 meter. So you can see that the unit of the meter, right, just cancel out, and then finally we can get the unit of the joules, which is the unit of the potential energy here. Okay, so now we just use the calculator to solve for this one. So I guess that you guys know how to use the calculator, right, to use the exponential function here. So after using the calculator, right, then the u here must be equal to the negative of the 5.73 joules. So that's gonna be the u. So then finally we can get the total energy, right? The E equal to the kinetic energy, okay, the 2.00, and then minus the 5.73, which is equal to negative of the 3.73 joules. Okay, so maybe you can just confuse. So why do we have the total mechanical energy to be negative, right? I would say that that's fine. Okay, so that's why nothing wrong about this one, because as I mentioned before, for this chapter, right, we said that the kinetic energy must be positive, right, because it's just 1/2 mv squared. The mass is positive and the v squared is positive, so that's why the kinetic energy of the particle must be always positive. But now for the u, right, the potential energy, it can be positive, negative, or the zero, right, depending on the reference level, remember. So now you can see that if the u is negative, okay, and it is the negative which is larger than the k, in this case the total E, right, the total mechanical energy can be the negative. So that's fine, nothing wrong about this. And one thing is that because right now we can find the total mechanical energy, right, equal to this one. So then this value can be applied to any position x of the point mass. Okay, it's not restricted only to the 5 meter, because we said that the total energy of the system must be constant, right? It must be conserved. So that's why this value is gonna work for all of the position x. So now for the part B, let's just sketch the graph of the ux. Okay, so we just want to draw the graph. Okay, because the x, right, by definition the x must be greater than 0. Okay, so let's just start from here. Okay, this can be the x, and then this can be the u, which is depends on the x. Oops. Okay, so how can we draw the graph? How can we draw the graph, right, of this one? Oops. Okay, to draw the graph here, right, let's just try to find the limit. Okay, let's just try to find the limit. So let's try when the x equal to the 0. Okay, so at the x equal to the 0, okay, with the x equal to the 0 here, you can see that, okay, with the x equal to 0, so e to the 0 equal to 1, but here we have the x equal to 0, right? It means that the u must be equal to the 0 as well. Okay, so the u here equal to the 0, so it's going to be at this position, right? So now let's find when the x just go to the infinity. Okay, when the x just go to the infinity here. Okay, so when the x go to the infinity, right, it means that this x go to the infinity and this one go to 0, right, because we have the e to the negative infinity, which is go to the 0. Okay, so now, okay, we have this infinity and we have the 0 here, but which one will tend to the 0 or to the infinity faster? Okay, I will just let you think a little bit. So which one, okay, will tend to the infinity or to the 0 faster? Okay, this x to the infinity faster, or this one will go to the 0 faster. Okay, so if you don't know how to work on this one, right, let's try to plug in the number into here. For example, maybe you can just plug in the x equal to the 5. Okay, let's try the x equal to the 5 here. Oh wait, no, wait, maybe 4. Okay, x equal to the 4. So when the x equal to the 4, right, so this equal to the 4, and this one equal to the e to the negative 1. Okay, so what is the e to the negative 1, right? The e to the negative 1 equal to this value. Okay, so now we can compare 4 and e to the negative 1. So you can see that this should be, I don't know, maybe less than the 4, right? Okay, so let's try to find another number. So here let's say, okay, when the x equal to 10, okay, when the x equal to the 10, so here we have e to the negative 10 over 4, right, which is equal to the 2.5. okay, let's try the e equal to the negative 2.5. okay, so you can see that it's just much smaller than, the 10. So then in this case we can conclude that this function, right, will tend to the 0 faster than the x, which is 10 to the infinity. Okay, so in this case it means that when the x just go to the infinity, right, the u will tend to be the 0. Okay, so this u is gonna tend to be the 0. Okay, but now it tends to the positive 0 or the negative 0. So you can see that we have this negative sign, right? So it means that it just tends to the 0 from the negative sign. Okay, so then the function that you can guess, it should be something like here, come down and go to like something like this, right? Because, okay, when the x equal to 0, the u is exactly equal to 0. But when the x go to the infinity, right, so the u just tends to be the 0 from the negative side, from this part, not from this part. Okay, now for the part C. Okay, determine the maximum kinetic energy of the point mass. Okay, just want to find the maximum kinetic energy of the point mass. So from the conservation of energy, right, we said that the total energy equal to the kinetic and then plus the potential energy. If you just want to get the maximum kinetic energy, it means that the potential energy must be minimum. Okay, the potential energy must be minimum. Okay, so we need to find, okay, the minimum potential energy. Okay, so let's say the u min, right? Because if we can find the u min here, then we can get the maximum kinetic energy from the conservation of the energy. So now from this graph, right, you can see that the minimum potential energy will occur at this position. Okay, so let's say that let's call this one to be the x min. Okay, and then let's call this to be the u min, right, the u min here, and the x min. So the x min is going to be the position where the u is minimum. Okay, but then how can we find the u min, right? So how can we find the u min? To find the u min, we need to find the x min first. Okay, because if we can find the x min here, we just plug in the x min into this equation, and then finally we can just find the u min, right? But then again, how can we find the u min? How can we find the x min? Okay, how can we find the x min here? So then again, it's just a curve here. Okay, it's just a curve. So we know that the derivative of the u, right, respective to the x at this position must be equal to the what? Equal to the 0. Okay, so don't forget that this position is called which one? Let me use this one. Okay, what is this point called? It's called the stable equilibrium, right? It's called the stable equilibrium. Okay, and then at this point, the du by dx must be equal to the 0. Okay, so we need to find the derivative of this u. Okay. Uh, okay, so let's do it, right? Let's just start from the u here. So we have du by dx, right, equal to the 0, okay, equal to this is constant, right? Just keep it. So we have the negative 4.00. Okay, so let me just ignore the unit joules per meter and the meter here. Just keep in mind that we have this unit already. Okay, so now for the first term, right? For the first term, okay, we have these terms multiplied with this term, right? Then the derivative of the x equal to the 1, and then we have only this one. Okay, we have the e to the negative of the x, and then over the 4.00. So now plus, okay, so we just leave the x as it should be, right? And then let's find the derivative of this one, of the exponential function, right? It's just equal to the exponential function, and then find the derivative of its argument, right, which is equal to minus the 1 over the 4.00. Okay, now we can just simplify. Okay, so now we can just simplify this one. I can just bring, okay, I can just bring okay, we have the negative 4.00, right? And we can just bring the exponential, this one, out of the parentheses, right? So we have the e to the negative of the x over the 4.00, and then times the 1. Okay, this is 1 because we just bring this out already, and then minus, okay, because we have this minus sign, x over the 4.00. Okay, so we need to get this function, right, equal to the 0. Okay, so it means that this is impossible. It's going to be the 0 when the x go to the infinity, so it's not in this case, right? Then the answer should be that this term, the last term here, must be equal to the 0, right? It must be equal to 0. So then finally you can get that the x min, right, must be equal to the 4.00 meter. Okay, so there's going to be this position, the x min equal to the 4.00 meter. Now then, okay, we can get that the minimum potential energy is, okay, the minimum potential energy is okay, the u min equal to, okay, this one, right? We have the negative of the 4.00, and then times the x, which is equal to the 4.00, right? And then e to the negative the x over the 4, so which is equal to the 1.00, okay, because the x here equal to the 4. So then finally the answer is equal to the negative of the 5.89 joules. Okay, so this is our u min, right, equal to the negative 5.89 joules. Let me just put the number here. Okay, we said that our total energy, right, equal to the negative the 3.73 joules. So okay, if we just want to write down our total energy, it should be maybe this line. Okay, it should be this line. So this is going to be our total energy, which is equal to the negative of the 3.73 joules. Okay, so then we just want to find the maximum kinetic energy, right? We just want to find the maximum kinetic energy. The maximum kinetic energy should be the difference between the total energy and then the minimum potential energy. So it should be this length, right? So this will be the maximum kinetic energy. Okay, so let's see. Therefore, the maximum kinetic energy is, okay, so then from equation, right, the Kmax, right, must be equal to, okay, so we said that the E equal to the K plus U, so it means that the K must be equal to the E minus U. Okay, so we have the E and then minus the U min, right, which is equal to, okay, the E is what? The E is negative 3.73 joules, okay, minus the 3.73 joules, and then minus, okay, so now for the U min, right, just negative of the 5.89 joules, which is equal to the 2.16 joules, and then this is the answers. Okay, actually I just did something wrong. So I mean earlier I just mentioned earlier that the K max, right, should be the difference between these two. Okay, but actually the K max is positive. Wait, let me think. Yeah, right. No, actually it's correct. Okay, so the K max here should be the difference between these two. Okay, so it's correct. And that's it, right? So now I think you will get the idea how we can find the conservative force from the potential energy functions. Okay, or you can just determine which force is conservative or which force is the non-conservative as well. Or you can just find the you can just find the potential energy function, right, coming from the conservative force as well. Okay, following these examples that I just gave you already.